Good morning, good afternoon, or good evening, depending where you are in the world. Thank you for attending the Trust No Device, How to Achieve Device Security and Compliance webinar. Before we dive into the presentation, I would like to go over a few housekeeping items. If you have a question at any time during this webinar, please use the Ask a Question tab located below the player. Your question will be addressed during the Q&A session at the end of the presentation. At the end of the webinar, please take a moment to rate this presentation and provide feedback using the Rate This tab below the player. There are additional resources for you to check out under Attachments below the player. You can download these items at any time. Finally, the recorded version of this presentation will be available using the same URL shortly following its conclusion, so feel free to share it with your friends and colleagues. Now, I would like to introduce you to your speakers, Mike Goldgoff, Vice President of Marketing at OPSWAT, and Yi Mao, OPSWAT's Vice President of Products. Over to you, Mike.
Thanks, John. Hello, everybody. I'm Mike Goldgoff. With me here in the conference room is Yi.
Hello, this is Yi. Welcome to our webinar.
And today we're going to talk about how to achieve device security and compliance. Should be an interesting session. There are a lot of things going on, as you know, in the market today. There are some fundamental changes that are happening, and really together they're creating really a perfect storm in how difficult it is now for security and IT professionals to really do their job and manage all these devices. So what we're going to do is really explore some of these challenges, and then we're going to define and recommend a solution. So we'll start with market trends that I alluded to. Then we'll talk about the traditional network access control and some problems with it. We're going to describe some of the new approaches to this issue that are available in the market today, and we'll move on to defining and describing a new solution. So these are some of the key relevant trends here. You know, applications are moving to the cloud. There are more and more different types of devices that are connecting to both local networks and to cloud resources. At the same time, we've got malware growing and vulnerabilities on devices and on servers and applications. And on top of that, there's really a complex compliance environment that you have to deal with. And these issues, they're not just a bunch of unrelated things. They're really interrelated challenges. One works off of another. So let's just jump in and discuss each in some detail. First, the cloud. So gone are the days when everything was on premises, all of your infrastructure, all of your applications with a firewall around them. Today, we're really in a hybrid state. You've got everything increasingly shifting to the cloud. And, you know, part of it is really this digital transformation that you hear about. More and more value shifting to data and to applications. And the way more and more businesses compete today is based on these assets. And as a result, they need to do everything faster. As a result, you've got all these DevOps processes and agile methodologies. And they are really driving businesses to the cloud even faster. So you've got you know, kind of a snowballing effect going on here. And, you know, this move to the cloud is accelerating the proliferation of devices. You know, you've got your laptops, mobile, even IoTs, and some of the trends around here are, of course, familiar to you. Consumerization of IT means that more and more employees are bringing their own devices to work. You've got really distributed enterprises and flexible work arrangements playing into this. You've got this whole concept of shadow IT. different departments building different infrastructures, and all of this really is contributing to the growth of unmanaged devices. And these devices, they connect to both personal websites and applications and work applications, including some of the business critical resources. So this is really a challenge to manage, as you know. And, you know, the real issue comes in here is when you look at what's happening from a malware and vulnerabilities perspective. So on the left-hand side, you see this explosive growth in vulnerabilities. And on the right-hand side, you see continued growth in malware. And you put those two factors together, you really have a perfect recipe for security incidents and data breaches. And in fact, we're seeing that. We're seeing every year, we're seeing more data breaches. They're increasing both in number and in severity. And really, things are getting worse, not better. So, and as this happens, you know, both industry organizations and government bodies are reacting to this. They're reacting with more and stricter regulations. And, you know, you really see some hefty fines as a result of that. And especially this year, obviously a lot of attention on this because of GDPR. You know, and GDPR, of course, that went into effect about 6 months ago, can result, if violated, in, you know, up to 20 million euros as a fine, or up to 4% of annual revenues. PCI, which of course continues to become more and more important. You've got, if violated, fines of $5,000 to $100,000 a month. HIPAA, there you've got, if you have a violation, you pay fines on a per record basis in terms of the health records that are being exposed, with a maximum penalty of up to $1.5 million annually for each violation. So how do we deal with these challenges? So let's take a look first at the traditional network access control. So what is wrong with traditional NAC? Well, many of you may have participated in deploying network access control over the years. And I don't know how your experience has been, but if you are like most other enterprises, you probably have encountered a number of these issues that I'm listing here. First of all, the problem with NAC is that it requires, the traditional NAC requires traditional network perimeter. And as everything is moving to the cloud more and more, you really don't have that. You don't have that, so it's getting increasingly more difficult to make NAC even work in this environment. Even if you can rely on a traditional perimeter, you've got some other issues having to do with how complex the integrations are. I mean, you'd have to deal with VLANs, network segments, and that results in very long implementation process for a traditional NAC solution, typically lasting months. Traditional NAC solutions also require expertise in both security and network design, and perhaps most of all, the problem is that they provide a poor user experience. You've got a situation where a user is getting their device blocked, they can't get onto the network, they're not able to remediate, and that, of course, is a major issue. So just to demonstrate some of these things, here you see a survey by Computer Weekly showing some of the main challenges of deploying NAC. Number one, network infrastructure integration issues experienced by over half of the participants. On top of that, and related to it, directory and authentication integration issues, another 30+%. You've got end-user resistance, which is, of course, related to, user experience. These things are complex to manage, to maintain, and at the end of the day, very expensive. Another key issue with network access control is how granular a policy can you really enforce on your devices. For example, one of the major requirements for many organizations is to look at whether the devices that are connecting to the network have encryption turned on. As you can see, over 3/4 of all devices we find are unencrypted or have encryption deactivated. And many, this is a real issue, and yet most network access solutions, traditional ones, have trouble dealing with the granular aspect of this requirement. In addition, here's another example. So what we're looking at here is high-impact endpoint vulnerabilities. And just to give you an example, the first one, CVE 2017-8527, allow remote code execution due to improper memory handling. Well, this is pretty scary, and you see that this is really occurring on over 9% of the devices out there. What's even scarier is that we've been able to correlate the vulnerability with the actual infection, with the actual malware. So again, let's take a look at the very first one here, 0199. What's happening here is that particular vulnerability is correlated to 11.4% risk of infection. Okay, so if traditional NAC doesn't quite cut it, what other approaches are available? Okay, so one of them is a zero trust model. You've probably heard of the model. It really talks about the current trust model in the market as something that's broken. And zero trust model implies and suggests that you need to eliminate the whole concept of trusted versus untrusted networks. So in zero trust, there are three main principles. You have to ensure that all resources are accessed securely. You really need to verify that every device access situation is authorized, inspected, and secured. Least privilege strategy, it's really about implementing privileged identity management. And finally, inspecting and logging all traffic and doing that continuously. So these are just some principles behind the zero trust model. And if you think this model is general, you're right, it is. So let's take a look at BeyondCorp. Now, BeyondCorp is, of course, something that was modeled at Google. It is a type of a zero trust security framework, but while zero trust is very general, BeyondCorp is much more specific and prescriptive. So BeyondCorp suggests, kind of 5 steps here. Securely identifying the device. They really talk about creating a database of devices and you're really treating all unmanaged devices as managed. You log every device and you try to treat it as a managed device. Similarly to that, you have a database of users and you apply SSO. You are really treating each network, even if it's implemented in a private address space, you are treating each network as an unprivileged network. And similarly with applications, you treat all applications even the internal ones as external. And finally, this whole idea of access control engine. So you give access to a specific device and specific user dynamically based on context, such things as location. This whole access control engine really controlling it. Finally, software-defined perimeter. Software-defined perimeter is more of an architecture, really, and it consists of a client, SDP client on each device. Then you've got the concept of the SDP controller, which really authenticates each interaction and grants privileges. And then you've got gateways that act as brokers to access resources. Now, with SDP, what you have is you've isolated your resources. They're completely dark to unauthorized users, and that allows you to really basically eliminate things like brute force attacks and some of the other risks that you've got out there. And the whole idea of pre-authentication and pre-authorization, before even a single packet reaches the target server, you must have the user already authenticated and authorized. So you've got the least privilege principle there at work. So now, having reviewed some of these general approaches, let's summarize the requirements as we see them. First of all, you need to have visibility into the network, the ability to discover each device and to identify it. A need for granular security checks for devices, inspection of each device. You need integrations with the rest of the security infrastructure, especially identity and access management. And the whole solution needs to be built for the cloud and friendly to this proliferation of different devices. Okay, so with that, I'd like to introduce my friend and colleague, Yi.
Hello again, everybody. This is Yi speaking, and thank you, Mike, for providing a very deep analysis of the market and probably all of the problems that are bothering you day to day if you're not already handling them. What I like to do in the following session will be defining a new solution. Basically, I want to propose something which not exactly at the approaches that Mike just described to you. However, as a soft food for you to take away from this webinar, and hopefully that it can somehow enlighten one of the processes that you're dealing with and maybe one of the solutions that you will be looking for. So before I dive into the definition of solution, I would like to first, again, highlight what is the problem that we're trying to solve here. First, again, this is not the first time you see this diagram. However, that the problem today is not truly related to the user identity, but is more related to, do you really know whether the same user or the authenticated user that you have with your access management system are using the correct and the compliant devices and the non-risky devices to access all the resources? Because these are two separate identities, and that represents the user in different aspects. I'm going to explain a little bit more details in the requirements. First of all, what are the actual required functionalities that we're really thinking about to actually benefit the general public? We believe that the device need to be going through some sort of very complex and thorough investigation before any access can be even provided. So that includes, but not limited to, the following areas. You want to know that the applications that's installed on the systems are those risky. You want to actually understand what is the working state of this machine in terms of whether there are active malware running on this system? What about the open vulnerabilities and the unpatched system that may also concerns you? And last but not least, you want to have a very clear understanding of whether this solution can actually be seamlessly integrated with some existing ecosystem that you already built without a huge disruption by introducing the new solutions to your current infrastructure. So what we are looking for and what we're thinking about the integration options, because of the cloud applications are gaining more and more popularity, we believe that first the solution needs to be very, very cloud friendly. We believe that the solution needs to offer the modern APIs that can be easily integrated with any of your current solutions that's already deployed, or you're considering, to pair up with, this device access control framework that you want to adopt. And on the other end, as we all know, that many corporations already implemented NAC solutions, and a lot of these NAC solutions that have, a client piece that's sitting on endpoints that builds, secure network channels to get access to your on-premises resources. So maybe an integration on the client side will also be considered as a migration plan before your organization completely moves to the cloud. So can such a solution even exist? I will leave that, to the very end. So a little bit more deep dive into some of the compliance and the device security requirements that I'm pretty sure that you will probably hear from different sources. Very first thing that most people are concerned about would be the endpoint compliance. So how do we define that? Obviously, different regulatory requirements will need very different requirements for the endpoint compliance. They want you to be able to detect as many security applications as possible installed on the system and report correctly of their working state. For example, is there any anti-malware applications running and the real-time protection being turned on? And what are those anti-malware applications? Is the device actually encrypted and what level? And does the user enable the user authentication on the system at all? And how about the system patch level? Is it most up to date, or it's missing a very critical patches that is highly vulnerable? You need to have granular controlling policies in order to define those for different groups, different users, and probably even different networks. The second requirement is basically the endpoint vulnerability management. As Mike kind of showed, there is explosive growth in the vulnerability on endpoints that are being associated with a variety of data breaches and attacks. So we all understand every single application has open vulnerabilities, and those are continuously growing and being validated. So I believe the requirement here is, first, you may want to have an application inventory that you kind of know what has been deployed and installed, either through the IT or with the BYOD devices, or actually completely shadow IT. You want to understand that how many open vulnerabilities that you may encounter as these devices are onboarded to your cloud or your local network. And you want a very timely updates to report back of all these open vulnerabilities. And last but not least, you want a prioritization for your IT team, because they can be facing thousands of vulnerabilities daily, and they don't really know how to prioritize the patches and what to focus on first. The last one, it's a common understanding of endpoint security, which is basically malware detection. So here, we would like to propose that maybe the requirements should really change, that by having a single anti-malware application on the device will not be enough to protect the organization. our research actually shows that multiple anti-malware and applications have their own strengths and weaknesses, and there are ways that for malware to escape from one protection, but not the others. So if at all possible, to employ a solution that has multiple anti-malware applications scanning the data traffic would be desired. Another thing, but last but not least, around malware on endpoint is some of the behavioral analysis. For example, that you may consider that deployed a real-time protection, enabled anti-malware is protecting the device, but in a lot of cases, a user behavior can completely change the landscape. Someone may be continuously downloading a plugin or a toolbar which is considered malicious, and the local anti-malware failed to quarantine. You may actually have scenario that a user keep accessing unauthorized websites side by side to your very critical corporate resources, and the same threats being introduced on the same machine into your network. So these are the some of the requirements that I want to drill down a little bit, just for you to think about. So circle back to my first point is, can such a solution actually exist? Is there a way that you can adopt a solution that basically it provides a single pane of glass for endpoint vulnerability compliance and malware detection in one single solution, and it can be very easily integrated, with almost no disruption to your current network, configuration or layout, and enable, BYOD users or managed devices to onboard to your local network or cloud applications, and you actually have visibility onto those devices to ensure that you have the right user at the right moment with the right devices and trying to access the resource they're supposed to. So with all of these being said, I would like to welcome you to raise your questions to both Mike and myself, and we'll help you to answer as much as we can.
All right, sounds great. Thanks, Yi. So we do have a variety of questions from the audience. I think the first one is just some housekeeping questions. Two people asked, will you be providing the deck, and can we get the slides? And the answer is yes. We'll post it probably about an hour right after this presentation, so you can come back later today, go into the attachment section, and the deck will be there. So on the technical side, it looks like a couple questions regarding the solution that Yi was talking about, and we'll start with a simple one. Is the solution required to have an agent on each device?
Yes. So the answer is yes. We believe that a deep analysis of the endpoint is absolutely necessary in order to achieve all of these requirements that was defined earlier, because of the agentless approach in general does not gain enough insight of what's actually going on to the device. And you do not want the solution to be too smart to make assumptions only based on the network traffic that goes around. And the device literally cannot be trusted, and a lot of facts and the data has to be collected from the roots. And then you combine the solutions all together with all of these insights, then you can come up with a very credible conclusion that this is the security posture that you're looking for before the user and the devices are getting into your network or access to your cloud services.
Okay, great. Thanks, Yi. Got a few more. This one looks pretty good. Do you need an in-house cybersecurity and or networking expertise to implement the solution?
Yeah, that's a great question. I think the advantage, or almost the requirement today, the problem is there is a huge shortage of resources, both in cybersecurity and in the network side. So for a solution that we described, you only need minimal resources. It really integrates with external identity providers and makes it really simple.
Okay. Here's another one that just came in. How long does it take to assess a device?
So I'll take the answer. This will be depending on how thorough the investigation needs to be done because of the variety of security applications has different status to be collected and being assessed. With the policy being defined, if let's say the assessment is only looking for an anti-malware status or the encryption of the disk, it could literally only take seconds. But if it needs a deep analysis of, the threat activities on the endpoint or, some more deep level understanding of all of the applications that's installed and vulnerabilities being displayed, it could take a little bit longer. But based on our research, no assessment should take more than 15 seconds.
Okay, great. Thanks, Yi. It looks like we've got 2 more questions. And just as a reminder, if you want to ask a question, just hit the Ask a Question tab located below the player. So here's, this one is, how do I implement if I have deployed an IDP solution such as Okta?
Yeah, so as we kind of mentioned in the earlier architecture diagram, we believe that nowadays, for whoever adopting the cloud applications, we assume that you want to adopt as many as you can for productivity. So an IDP is almost become a requirement to be deployed together with all of these cloud applications. So the approach here is to not disrupt the authentication flow of the identity management solutions. Let the user authenticate clearly through the identity management system as seamless as possible. Once the user identity has been verified, there will be a additional decision maker. So you can consider as a additional factor of the multi-factor authentication that you're already having to validate the device status. And then, end of the day, the solution can be very easily, either denying the access based on the device security status or forwarding and allowing the access directly onto the destination. So it is as seamless as you would expect from a cloud-to-cloud integration.
Okay. Here's one that just came in. It's kind of phrased as a statement, but I'll phrase it as a question. It says, 15 seconds sounds very fast if I want to assess the patch compliance on a machine. So if we can maybe comment on that.
Sure, we can. So when I mentioned the 15 seconds, also I believe that one of the areas that when we are assessing the data is not always scanning the same thing over and over. That is the power of having the cloud, inventory always being kept there. So you have almost a live database that captures all of the system updates and inventory of your deployments or applications in the landscape. And then each update of the endpoint status is not, doing a full-blown, thorough assessment all over again. So a lot of data, depending on how frequent that you want to assess the device compliance status, it can take, longer and shorter if you truly enforce a full, thorough investigation every single time, or piggyback onto some historical data. And of course, the historical data could be, every 15 minutes, 30 minutes, or an hour. And we have seen even some, customers deploying, in a sense of, last 24 hours, if the device has been assessed once, it's already meeting the compliance requirements. So again, it all depends on how aggressive and how fresh the data need to be.
And of course, if I could add, the flexibility of setting policy and determining these are, of course, the key.
Yes.
Okay. Looks like I think I'm going to wrap up. I've got 2 more, and then we'll wrap up. Here we've got this one. How does this solution work with EPP EDR systems?
So EPP EDR systems are not at all, conflicting or let's say, they actually go hand in hand. So when we are basically looking at the applications that we propose here is to assess even the EPP and the EDR are actually working properly, because it's similar things as the anti-malware applications that most IT will assume that every application is working perfectly fine and that they're being configured properly. But the reality is that sometimes there are errors and local issues that these systems are actually not functioning, and you need basically another watchdog service to help you understand, do I have a problem with this? Now the question is that you may say, okay, I already have a central dashboard that monitors my EDR EPP deployments, but what about another anti-malware being installed? What about your corporation, and also because the BYOD use cases, the user chooses to deploy a different EDR, which you're not managing. So you want to know those status, and we would say that it's agnostic to any of these endpoint protection applications that's already installed and deployed that's protecting the endpoints. You need just someone to be able to reflect their true status and knowing whether this device is truly protected.
All right, and I think this will be the last question that we'll take, which is, why is the new solution easier to implement than traditional NAC?
Yeah, so just caught another question which is very similar. I'm going to read it off as well. How does your solution compare to Cisco Ice? So I'm going to answer both questions at the same time. So as Mike kind of spent a bulk of his presentation about some of the NAC issues, is that first, you can always adopt, or if you already adopted Cisco Ice in your environment, or you upgraded from the old Cisco NAC solutions, this also actually works hand in hand with the NAC. As mentioned, that what about the granular policies that you do not get from the Cisco Ice? What about all these very complex, compliance check, application detection that the turnaround from the Cisco Ice is, from our experience, anywhere from 3 months to 6 months to add a new batch of detections for new applications in the market? How vulnerable your devices in the field are because of missing detections for all of these applications. So we believe that the solution is actually completely augmenting, even if you already have Cisco Ice deployed or you're considering, that this is a much lighter weight deployment. This is a much seamlessly cloud-native approach to address a modern problem, instead of, piggyback on some old infrastructure. But it can still provide this migration seamlessly until your solution or your organization consider to move 100% into the cloud.
All right, excellent, Yi. I think that actually covers all the questions. I just want to remind everyone again that you can go in and get some of the attachments that we posted, and we're also going to go ahead and post the deck in probably about an hour. So if you want to go ahead and grab it later today or another time, please go ahead and do so. So again, I wanted to thank our presenters, Mike and Yi, and thank you for participating in Bright Talks Cloud Security and Compliance Summit and going through our presentation on how to achieve device security and compliance. Great, thank you.
Thank you very much.
Thanks.